the logarithms, and you're going to do most of this on your own or within your pod. So what you're going to do is you're going to take out a calculator. Any calculator has a log button on it. Notice I'm asking for log base 10, Charlie. I'm asking for log base 10. Log base 10 is the only one you can do in your calculator. I lied. You can do log base E. That is your ln button. But if this was log base 3, we couldn't use our calculators today. But it is log base 10. I'm looking for log base 10 of 1. So all we're going to do is we're going to go to our calculator, make sure it's on, clear out what I did. You're going to hit this log button right here. This is log base 10. I reiterate, it is log base 10. If you have log base 2, you can't use this button. All right, this is just log base 10. So we're going to do log base 10 of 1. We're going to hit enter, which is going to come out to 0, so we're just going to put a 0 in that spot. I'm also going to note that we're going to round everything to 3 decimal places, and that's going to be needed for log base 2. So we're doing log base 2. Log base 2 is going to be 0.301 rounded, so that's going to be 0.301, and I'll move on. What you're going to do within your pods, you're going to fill out this whole thing. And then you're going to do each of these. Note, log base 3 plus log base 5. All you're going to do is find that value. So once you have log base 3 and 5, you're just going to take whatever's there, plus 5, and you're going to put that right there. All right, that plus there is going to go there. For the next one, notice this is log base 10 of 3 times 5. Well, you're just going to be looking for the log of 15. Which should be right here, so you're going to put that answer right there. And then you're going to put that together and come up with some kind of notion of what this product property would be, and then do all of them. Do all of the properties. And while you guys are doing that, I'm going to hand I got, for log base 10 of 3, I got 0.477, log of 4, 0.602. Yeah, log of 5, 0.699er. Then I got 0.778, 0.845, 0.903, 0.954. 10 is just 1. 15 is 1.7, 1.176. And finally 1.505. Cuckoo, kachoo. All right, so for our very first one, we are supposed to take log of 3 plus log of 5. Well, log of 3 is 0.477. So what we should be doing is doing 0.477 plus log of 5. Log of 5, log of 5 is 0.699. What does that equal when I add those two things together? Someone, anyone. Teresa. Say that again. And the other one we were supposed to do log of 3 times 5. Well, that's just 15. What is the log base 10 of 15? Someone, anybody, help me out here. Charlie. 0.33. No. 1.176. Yes, 1.176. Because if I go up here, log base 10 of 15 equals 1.176.
Oh, okay. We're good.
Okay, so we should have came up with a product property that was basically saying, well, if I have the same base and I'm adding two things together, I can rewrite that as a multiplication of those two. So we're going to have log base b of m times n. So as long as they have the same base and an addition sign between them, we can change it into a multiplication inside. And this is known as the argument, if you want to call it something. So the argument would be m times n. Our next one is log base 10 of 6 minus log base 10 of 2. Who got that? What does that equal? Olivia? Say that one more time. 0.477. And what happens when we look for log of 3? Well, log of 3 is 0.477. It's right there. So when we have addition, we change the argument to multiplication of the two. When we have subtraction, we are going to change it to division. So we can rewrite this as log of b of the m divided by n. Be careful though. Your first number is your numerator. Your second number is your denominator. It is in order of how it's listed, but order definitely matters when we're using division. Multiplication, not so much. If you write it n times m, still come up with the same answer. This, you're going to come up with a completely different answer if you order wrong. All right, I have log of 2 to the 5th. Well, that is just log of 32. Log of 32, well, that's just in my list. That's 1.505. The next one says do 5 times the log of 2. Log of 2 is 0.301. So I'm really doing 5 times 0.301, which is going to equal 1.505. What that tells me is if I have an exponent here, I can actually bring it out front. So I can take that exponent and bring it out front. I can also take that, if it's in front, I can bring it and turn it into an exponent. So log base b of m to the x can equal x times log base b of m. And we're going to have to know how to go both directions because we're going to do something called expanding and condensing. So we'll break stuff all the way apart and then we'll put it all back together into as small of an expression as we can make it. Those additional properties, we already talked about those. That's nothing new. These additional properties are nothing new. Let's go ahead and do an example of each. So this one, and I'm going to do it in red, part of it. So if I had log base 3 of 3 squared, it looks really complicated, but just remember, logarithms are inverse of exponents. So same base logarithm undoes same base exponent. So what's happening here is that log base 3 cancels out that exponent base 3, and you're left with 2. The same thing happens with this one. Let's say we have a base 9 exponent. We have log base 9 of 4. Base 9 exponent undoes log base 9 logarithmic function. So that 9 and that log base 9 are going to go ahead and cancel out because they're inverses of each other, and we're just left with 4. It seems like we just did this, but for some reason when I put these into solve or simplify, people kind of forget about it. So if you have the same base logarithm and an exponent, they just cancel out. Same base exponent with log, they just cancel out and you're just left with your number. And that is part of your homework. There is a section on that if you recognize it, it'll be super easy. If you don't recognize that, it will be really hard. All right, the first thing we're going to talk about is condensing. We're going to condense as far as we can with these. So in general, we're going to condense it down to 1, maybe 2 different equations. Well, we're starting off with 1/3 log m minus log of n. When we are condensing, when I'm putting something together, we're going to use PEMDAS to do that. PEMDAS tells us to use parentheses first. There's no parentheses. Then we're going to do exponents next. This 1/3 out front of here can be turned into an exponent. So that's going to be the first thing I'm going to do. Because this property right here, our power property says that if I have a number in front, I can turn that into an exponent of our argument. So what I'm going to do first is my exponents. So I'm going to turn that right up there on top of the m. And we're going to that equals log base m to the 1/3. I'm going to put that in parentheses so I don't mix stuff up. Minus log of n. 1000% necessary, but generally speaking, I don't like m to the 1/3. It's kind of like if I had m to the 1/2, and I'm not doing anything with it. I'll put it as a square root, cube root, to the 4th power root, just so we don't get lost with these weird exponents. So not a huge deal, not necessary in this problem, but just for aesthetic appeal, I always turn this into a cube root of m minus log of n. All right, now I'm going to see the subtraction sign. If I'm subtracting two logarithmic functions of the same base, I'm going to point that out one more time. These are the same base. That's the only reason why we can do this. Subtracting logarithms of the same base is going to be the same thing as dividing by the arguments. So that's log of cube root of m divided by n. And that's as simplified as we can go with that one. Our next one, we're using PEMDAS again. So I'm going to look for if I can find exponents first. And we do. We have this 6 out front and this 3 out front. We can turn those into exponents while condensing. Condensing, we're pushing everything together. After this, we're going to break everything apart. So while condensing, I want to push that 6 in here. So we're going to carry that 6 and turn it into a power of the argument. We're going to take that 3 and turn it into a power of the argument. Do not use the negative. All right, the negative is going to be division. Make sure you just use the positive 3 right there. All right, so that's going to equal log base 5 of x to the 6th plus log base 5 of a y minus log base 5 z cubed. Once again, do not take the negative. Don't take it as the negative. Now, in order to push all this stuff together, they have to have the same base. So I'm once again going to check to make sure they all have the same base, which they do. They're all base 5, so they all have the same base. So I am allowed to use that product property and that division property. With PEMDAS, this is why I keep saying PEMDAS. We do our exponents first, then we do multiplication and division. Well, these are going to be multiplication and division. They have the same power within PEMDAS. If you have the same thing going across, you work left to right. So we are going to work left to right to do my next thing, because they both have the same power. Multiplication, division, you don't do any one in front of the other. In that case, you work left to right. So I'm going to work from here to here. So I'm going to look at that addition sign first. That addition sign tells me I am doing my product property. So I'm adding same bases, so my arguments are just going to multiply together. So in my next step, I'm going to have, this is going to equal, let's go back to black, log base 5 of my first argument, x to the 6th, times my second argument, which is y, minus log base 5 z cubed. Took care of exponents, took care of left to right. Now I just have that negative sign in there. That negative sign tells me I'm going to use in the division, our division property, or quotient property, which tells me if I have a subtraction, I'm going to divide my arguments. So we are just going to have, in the end, log base 5 of argument 1, which is x to the 6th, times y, over argument 2, which is z cubed. We can't simplify any further. That is a condensed expression. On the next page are two more right on the top. I want you to go ahead and do those two. Look like most people had it correct. Handle the powers first. So my exponent first, so I'm going to change that into log base 10 of 2 cubed minus log of 4. Well, 2 cubed is just 8. So maybe in my next step I just say log of 8 minus log of 4. Subtraction tells me I'm going to use that quotient property. So we're going to have 8 divided by 4. So we'll have log of 8 divided by 4, which equals log of 2. The last one, exponents first. So that's going to equal log base 2 of x cubed plus log 2y. That addition tells me I'm using the multiplication. So we are going to multiply our arguments. So we're going to have x cubed times y, and that is fully simplified. All right, so that is condensing. That is taking a bigger thing, pushing as small as we can in there. Our next thing we're going to do is we're going to expand. That means we're going to pull everything out. So where I put exponents in, I'm actually going to pull exponents out. I'm going to pull apart multiplications. I'm going to pull apart divisions. All right. So we'll start with log base b of x squared over y. The first thing we're going to do is we're going to handle, so when condensing, we use PEMDAS. When expanding, we're going to go the opposite direction. We'll do our multiplication and divisions first, and then we'll do the exponents second. So this one we have a division bar. I have something on top, something on bottom, so I'm going to handle with that division bar first. Well, division, we're going to turn that into subtraction to expand it. So rather than having log base b of x squared y divided by z, we're going to change that into a subtraction of two logarithmic functions. So I'm going to have log base b of x squared times y minus log base b of z. That gets rid of that division bar in the arguments. Now I'm going to get rid of that multiplication sign. Multiplication leads to addition. This multiplying is going to lead to the addition of two logarithmic functions. So we're going to have log base b of x squared plus log base b of y. And we still have that minus log of b of z. The last thing we have to do, because we want to pull this apart as far as I can, this 2 is still condensed. It's pushed into there. So to end this, I am going to pull that 2 out front. That's my last step. So we're going to have that equals 2 times log base b of x plus log base b of y minus log base b of z. And that's fully expanded. Our next one is ln of square root of 1 minus x over 4. Don't forget, ln just means log base e. That's just log base e. It's just a number. But we need to recognize that ln is log base e. So anything I do with log base b is the same thing I can do in letter b. We're just going to do it with ln's and leave them as ln's. So the first thing I'm going to recognize is that division bar. I'm going to get rid of that division bar. So I have ln of square root of 1 minus x minus ln of 4. So if I'm dividing in the argument, I'm going to change it to subtracting two logarithmic functions, which is just log base e in this case, or natural log. We really do have exponents. So don't forget, square root of 1 minus x is really 1 minus x to the 1/2 power, because this is really square root, so we just put that 2 underneath that fraction bar of our exponent. But we're still subtracting ln of 4. So my last step is to pull out the exponent, which is going to equal 1/2 ln 1 minus x minus ln of 4. Here's the place where people go too far. Here's the place where people go too far because they see this 1 minus x and they try to do something with it. Well, just remember what our properties say. Let's go back to our properties. We have to have multiplication in the argument, division in the argument, or an exponent in the argument. Those are the only 3 cases I'm looking for. So if I go back to the problem I'm on right now, I don't have multiplication, I don't have division, and I don't have an exponent in the argument. So there is nothing more I can do. This is actually our finished answer. In the argument, the only thing you can tackle are multiplication, division, and exponents. Anything else, and you just leave it as is. All right, once again, go ahead and do that C and D. Try to do those on your own or within your pod. All right, let's go through these. So we're going to work backwards. So once again, and I'll say it a billion times, I don't think many people put it in their notes, we follow PEMDAS to condense, and to expand, we go the opposite direction. So exponents and stuff are going to happen last. So in this case, exponents happen last, so I'm going to tackle that multiplication first. So I really have a cubed times b to the fourth. Multiplication in your argument means to expand it, we're going to use addition. So my next step is log base 3 of a cubed plus log base 3 of b to the fourth. Now we'll tackle our exponents. So now I'm going to have 3 times log base 3 of a plus, carry that 4 out front, 4 times log base 3 of b. Last one, I'm going to rewrite the last one just a little before I do anything else. Because right now I have a square root and an exponent. Well, square roots are just exponents. Square roots are exponents. So I'm going to rewrite this as log of p. Let's just write it as is. P to the 3 to the 1/2. So it's log of p to the 3. Maybe I should put this in brackets so nothing gets confused. So it is log of p to the 3 to the 1/2. Well, when you have a power to a power, you multiply. So this is 3 times 1/2. So what we really have is just log of p to the 3 divided by 2. Well, that means the only thing I need to do is I need to pull out that 3/2 out front. So that's going to equal 3 divided by 2 of log p. And that is finished. All right, that is it. Most of your homework is just rewriting expressions in single or expanding. And then there's some that you have to put in a specific type of thing. Like in 17, 19, 21, it says rewrite each expression in terms of log base a of 5. So you just got to manipulate it so you have log base a of 5. All right, questions from the homework that was due today. Oscar.
Like just a general question about the class.
Mm-hmm.
So like for the domain. Actually, never mind.
You sure?
49. Number 49.
Number 49? Okay.
The logs.
All right, number 49 is the natural log. It is probably the biggest thing that's going to confuse you and trip you up when you get to calculus. And it's because people see natural log and they think it's something really special. There are some special rules with it when you get to derivatives and stuff. But right now, I want you to think about the fact that this is just log base e of 5 equals x. That's all it is. Log base e of 5 equals x. That's what I'm looking at when I'm looking at ln of e, or ln of 5. Well, that means all I need to do to get rid of it is have an exponent with base e. Exponent base e cancels out logarithm base e, which means I need to do the same thing to the other side. So I am just left with 5 equals e to the x. E is just a number. Treat it as just a number. Okay? Does that make more sense?
Is that the final answer?
Yeah.
Oh, okay. I also have another question.
Mm-hmm.
So for like the first couple of the homework. It's like 17 and 19.
Mm-hmm.
Like, on the answer key you had that there was a 10. It's like, it was like log base 10. So
Mm-hmm.
is that what log it normally is? It's like if it doesn't have another number.
If it doesn't have a number, another number, it's automatically 10 there.
Okay.
Just like ln is always an e, log base e.
Okay.
Log of 10, or log of any number without a base, automatically means it's log base 10.
Okay.
Yep. Shh, guys. Other questions? Jack.
U68.
Yeah. Um, 68. We are supposed to find the inverse of this function. So we are starting with, I'm just going to, instead of have fx, I'm just going to put y equals log of x plus 4. So the first thing we need to do is we need to switch our x's and y's. So we're going to have x equals log of y plus 4. Now I need to solve for that y. I need to get that y out. Well, the only way to get that y out is to get rid of that log. And just a reminder, if there is no base here, it is automatically base 10. If there is no base, it's automatically base 10. So let me just shift this over really quick so I have a little bit of room. To get rid of log base 10, we are going to have an exponent base 10, which means I need an exponent base 10 on this side. So that means now my logarithm base 10 is going to cancel out with my exponent base 10. So that means I'm going to have 10 to the x equals y plus 4. I didn't fully solve for y yet. I need to get that by itself, so I'm going to subtract 4 on both sides. And I'm going to end up with y equals 10 to the x minus 4. Is that good, or do you have questions about why I did?
Understand how to, like, where you go after you have, like, the log and then y plus 4.
Oh, okay. Yep. Same thing. Same thing. Just get rid of the log and then subtract, just like we would do any other problem. Other questions? Going once, twice. Yes.
81.
Yeah. Specific question?
Just like how to start it.
How to start it? There's two ways to start it. So we have ln of x minus 3 equals ln of 2x minus 9. You could use the one-to-one property and realize that both of these are log base e of the same thing. So this would have to equal this. Or if you didn't recognize it, you realize that, well, ln is just base e, so I would just raise both sides to an exponent base e, because it's just log base e, okay? ln is just log base e. In which case, that e and natural log would cancel each other out, because it is just log base e.
Oh, okay.
Do you need to see that written out, or?
Well, no, I get that.
You get that? Okay.
So
And then it's just, yeah, x minus 3 equals 2x minus 9, and you just solve for x. Are you sure you're okay with that ln and the e canceling out?
Yeah.
Okay. Awesome. All right. Then the rest of the time is yours to work. I'm going to circulate. I'm going to check your homework really, really quick. I think I have like 2 minutes to do it. I can do it.